Okay, this is lesson 6.6, transforming sinusoidal functions. We are being asked to find the equation of this sinusoidal function. So they're not giving us the equation and asking us to graph this time. They're giving us the graph and wanting us to find a suitable equation. Now remember one thing, when they say sinusoidal, we can use either a sine graph, a sinusoidal function in terms of sine, but sinusoidal is also a term applying to cosine. So you have a choice as to which one you want to use. Usually cosine's a little bit more easy to determine, especially the phase shift, because you're looking for a maximum. So we'll go and find A, B, C, and D in that order to get this problem started. Let's start with the A value. As I've told you before, I think it's a good thing to take a ruler and draw a horizontal line along the maximum as well as along the minimum and then along the central axis. Just a quick calculation, we're working from 6 to 4, so that's a 10 unit difference. So 1, 2, 3, 4, 5. The central axis will be the average of 6 and -4, which will be +1. Okay, so we can definitely see that the distance from the central axis to the maximum is a total distance of 1 to 6, which is 5. So we'll just write down 5 over here for the A value. That's your amplitude. Next, let's go to the D value, deal with the Y values first. D is your vertical shift up or down. The central axis has gone up 1, so D is clearly 1. B is your horizontal stretch of compression. It's the period that will help you determine what the B value is. Remember, for sine and cosine, your typical period is 2 pi. So I'll just write that down here below. Let's see what the period is for this graph. To figure out what the period is, I'm going to look at this minimum repeating to this minimum. So that would be a full period from one minimum to the other. Well, what is the x value for this period? Well, it's halfway to a sixth of pi. Half of a sixth, one-sixth times a half is a 12th. So this would be pi over 12. Now let's just double check these increments to make sure that's right. So this would be 1/12. This would be 2/12, which is pi over 6. This would be 3/12. This would be 4/12. Is 4/12 the same as pi over 3? Definitely. Okay, so I'm just going to count the boxes in 12ths now. So we got 1, 2, 3, 4, 5, 6, 7, 8. This is 9/12. I'll just label this here. 9/12 pi. And what's 9/12 pi the same as? That's the same as 3/4. Okay, so the total distance from pi over 12 to 9 pi over 12 is a distance of 8 pi over 12. I'm going to label the period here in red. That's a horizontal distance of 8/12 pi. Now that simplifies to be 4/6, which also simplifies to be 2/3 pi. So I'm going to write that down here. 2 pi over 3. Okay, so the period is now 2 pi over 3, and in the original parent function of sine or cosine, the period is 2 pi. So that is clearly a smaller period. So we have a horizontal compression. So how do we go from an original period of 2 pi to 2/3 pi? Well, that's basically taking 2 pi and dividing it by 3. So we would call that a horizontal compression of a third. If you take 2 pi and multiply by a third, you get 2 pi over 3. Okay, so I'm just going to make note of that over here. The B value would be 1/3. Whoops, I almost got fooled. B is bad, remember that. B is bad, it does the opposite. So the B value would be 3, and a B value of 3 is a horizontal compression of a third. Just going to make note of that here. So if we multiply 2 pi by 1/3, you get 2 pi over 3, which is our new period. So that's correct. And now the last one is the C value. That's your phase shift. What is our phase shift? Well, it said at the beginning a sinusoidal function, and a sinusoidal function applies to both sine and cosine. I'm going to start with cosine, since usually cosine's a bit easier. If I look up here, cosine has a maximum, usually right on the y-axis at 1. This maximum has been shifted to the right. Well, how far to the right has this maximum been shifted? Well, remember before we said that each box is a 1/12 of pi? So let's just count. 1/12, 2/12, 3/12, 4/12, 5/12 pi. Just check that again. 1, 2, 3, 4, 5/12 pi is our phase shift. So we'll go 5/12 of pi. And that is to the right. You don't have to state the direction for your phase shift, but I'm going to because it will help me in the stating of the equation. So there it goes. Okay, we're ready to type up our equation now. So I'm going to pull up a little equation editor so we type this correctly. So it would be y equals 5. Y equals 5, and we picked cosine first, so it would be cos. Now our B value is 3. Now our phase shift, it's to the right, so it's x minus 5/12 pi. So 5/12 is a fraction. 5 tab 12, 5/12 pi. Okay, so there's our phase shift. And then we said the D value is up 1, central axis up 1. Well, there you have it. Y equals 5 cosine B value 3 bracket x minus 5/12 pi plus 1. That would be one possibility for a sinusoidal function. If we wanted to also state an equation in terms of sine, one that would be possible could be y equals 5 sine of 3 bracket x minus something. Remember, as we said in class, if we want to state the function in terms of sine, A, B, and D are all the same. The only thing that changes is your phase shift, the C value. Well, let's revisit this graph for a second then. I'm going to pull out a purple marker. For sine, typically we looked here on the graph at 0, 0 for a starting point. Well, where has the starting point gone? The starting point has gone up 1 for the central axis and has gone to here. Notice that this point at 3/12 pi x and 1 for y is where sine's starting point has shifted. Notice it's halfway between the min growing to the max. So that is a possible starting point. We could also use this one over here as it has the same characteristics. But I'm going to use this one. And it is 1, 2, 3 pi over 12. 3 pi over 12 is the same as 1 pi over 4. So to my sinusoidal function, the only thing that changes is your phase shift, and the sine phase shift would be pi over 4 to the right. And there you have it. Okay, so there's two possible equations in terms of sine. So everything looks good there. I just want to show you something that is kind of troublesome with our TI-83 graphing calculator. If you try and type in this function, let's type in the sine function. Notice what happens after you type in 5 sine. It automatically puts up a bracket where we want to actually take out the b value of 3. Okay, so one way to get around that is to add a second bracket, an opening bracket, put in a 3, and then close the 3, okay, and you're still going to take the sine of 3 times something. So now we can open a bracket again and input what we have there, x minus pi over 4. There's x minus pi over 4. And then since we have open, open, close, open, I need to close it 2 more times. So that's 3 closes. That should work. And then I have plus 1. Okay, I'm going to press graph for a second here. Oh, go to my syntax error. I made an error here somewhere. Oh yeah, I have too many of those closed brackets, so I'll delete that one. Make sure my mode's in radians. Oops, I got to switch that to radians. And then, as I told you in class, zoom trigonometry will allow the x-axis to be broken into pi over 2 values. So press enter on zoom trig. So let's see if this looks like the one that we have on the page. Well, the window's definitely a lot bigger than what we have on the page. Why don't we change the window to see better if this matches up? Let's go to window. Let's change the minimum, not all the way down to -2 pi. Let's go as low as 0. And let's go as high for x as, look, we have 5 pi over 6. Let's put in just 1 pi. Second function pi. Okay, and the y minimum is -4. That's pretty good. But the y maximum on our screen, it goes up as high as 6. So let's put in 6, and let's press graph again. Now, does this curve look like the one that we're supposed to get? I think that's pretty good. Okay, if we want to just double check, we can just trace it. And is this maximum clearly over here at the peak where it's supposed to be, just a little bit more than half, a little bit less than half a pi? Looks good. Just going to double check it though. I'm going to find the maximum. Stat calculate the maximum. Stat calculate. Oops, wrong button. So I was typing that wrong. It's actually stat trace calculate. I'm going to just check a value. I'm going to check this minimum here at 3 pi over 4. Make sure that is where it's supposed to be. 3 second function pi divided by 4. It should be over here at this minimum. Is it? Yes, it is. See how it's blinking there? We've got it right. Okay. Continue on with 6.6.